Points of inflection on a graph are points where the concavity changes. That means that it might go from being concave up to concave down or vice versa. So if we want to find points of inflection, what we can do is we can analyze where the second derivative is either zero or where it does not exist. And the reason we can do that is because since the second derivative is positive when it's concave up and negative when it's concave down, if that derivative is continuous, then by that intermediate value theorem, to go from positive to negative, it would have to go through zero. So we can take a look at zero and take a look at the sort of neighborhood around it to see if it's had a change in concavity. And then if it doesn't exist there, we'll just have to analyze to the right and to the left of it. But the important thing to note is that just having zero as a second derivative is not enough. It's true that if it has an inflection point, one of these is true, but you can't flip it around. You can't say because one of these is true, it has to have an inflection point. An example would be like x to the fourth. If you take its second derivative, it's 12x squared, which clearly at 0, 0, the second derivative is 0. But you can see that it never changes concavity. It's always concave up. Versus x cubed, if you take its second derivative, you get 6x. But at 0, it changes from being concave down to concave up. So again, this is a good way to sniff it out, but it's not sufficient. You still have to analyze the surrounding area to determine whether or not concavity is actually shifted. So let's do some examples. I have this function. Let's take its first derivative, 3x squared minus 9x plus 27. And let's take its second derivative, which is 6x minus 9, which can be summed up as 2x minus 3. So what I see here is that when x is 3/2, the second derivative is 0. So that tells me that kind of my sniffing point. So what I need to do is I need to take a look at some numbers on either side of 3/2. So I have 3/2 and some numbers on either side. So let's take a look at 0 and 2, or 1 and let's take a look at 1 and 2. 1's less than 3/2, 2's a bit larger. So if I do f double prime of 1, I get 2 minus 3, which is negative 1, times 3, so it's negative 3, which is less than 0. F prime of 2 is 3 times 4 minus 3, so it's 3 times 1, which is positive 3, greater than 0. Since that changed, it doesn't matter, right, this one's concave up, this one's concave down. The fact that it changed, it doesn't matter if it goes up to down or down to up. The fact that it changed tells me that this is an inflection point. So x equals 3/2 is your inflection point. Now, similarly, we can do this problem here. We can say f prime of x is 1/2 cosine x over 2, because by the chain rule, it's cosine of whatever's inside times the derivative of the inside, which is 1/2. F double prime is negative 1/4 sine x over 2. So negative 1/4 sine x over 2. So we care about the closed interval 0 to 4 pi, but we really don't want to, we want to use the open interval here. So let's not consider 0 and 4 pi closed, because if we did, we'd have to look around it. I mean, we could, sure. Let's go ahead and do it. But just be careful that if you're working some kind of homework problem, that it may only care about the open interval there. So what we see is that this function is equal to 0 at 0. It's equal to 0 when x is 2 pi, and then again at 4 pi. Because sine normally at multiples of pi is equal to 0, but since this is 2 divided by 2, it's multiples of 2 pi. So then we just pick values. Since we're considering the endpoints, we actually need to pick values a little bit to the left. So let's say negative pi, pi, 3 pi, and 5 pi. So if I take negative pi, sine of negative pi over 2 is negative 1 times a negative here makes it positive. Sine of pi over 2 is 1. Negative flips it, makes it negative. So that tells me that's an inflection point. If I plug in 3 pi, sine of 3 pi over 2 is negative 1 times a negative makes it positive. 5 pi over 2 is the same thing as pi over 2 for the sine function at least. Sine of pi over 2 is 1. That makes it negative 0. So that tells me that all three of these are inflection points. Again, if you're working a homework problem, you may not consider the interval endpoints, but for the sake of what we're doing here, I'm considering them. So just be aware if you're working some kind of homework problem.